this is the biggest downfall of this whole model of finite scheduling is you're using a computer program to generate a plan.
Yeah.
So it's a bit of a black box, but then once you generate that plan, you print out your dispatch lists, you send those out to production.
Yeah.
And now you have a plan that immediately comes into contact with the reality of a production plan.
Growing a business requires a holistic approach that extends beyond sales and marketing. This approach needs alignment among people, processes, and technologies. So if you're a business owner, operations, or finance leader looking to learn growth strategies from your peers and competitors, you're tuned into the right podcast. Welcome to the WBS Podcast, where scalable growth using business systems is our number one priority. Now, here is your host, Sam Gupta.
Hey everyone, welcome back to another episode of the WBS Podcast. I'm Sam Gupta, your host and principal consultant at digital transformation consulting firm Elevate IQ. The needs of the production floor have always been the most critical for manufacturing, with scheduling being the most challenging function. The finite scheduling method has been the most accurate and most commonly used so far. It claimed to improve the on-time delivery by scheduling based on the due date and only working on jobs when they were due. But finite scheduling never worked as it didn't accommodate real-life scenarios such as machines going down or some resources not reporting when you were expecting them. Predicted flow manufacturing is the new method of scheduling that considers the real-time signals from the production floor and determines the priority of each job without missing the on-time delivery or needing to expedite at the last minute. In today's episode, our guest, Mark Lilly, shares his journey of being involved with several manufacturing ERP software and scheduling deficiencies in the visual manufacturing ERP software. He also discusses how predicted flow manufacturing solves the problems with finite scheduling available through the most commonly used manufacturing ERP software such as Visual, Syteline, or Epicor. Finally, he shares the integration and data requirements for the PFM module and how the scheduling needs vary across industries, including some of them having complex scheduling needs such as sequencing. Let me introduce Mark to you. Mark started his career in manufacturing software after graduating from Cornell with a degree in computer science. Working for Hewlett-Packard initially, Mark then joined his father's business, Lilly Software, where he sold and supported visual manufacturing to small to medium manufacturers. Mark later started Synergy Resources with co-owner Gene Caiola, now an 85-person VAR of ERP solutions and consulting focused on helping manufacturers improve their performance. For the last several years, Mark has been president and CEO of Lilly Works, funded and created by the same creators of Profiki and visual manufacturing. Lilly Works is focused on helping manufacturers manage production, what you may typically call production scheduling and material planning, with a new approach called Protected Flow Manufacturing, PFM. PFM implements within 60 to 90 days, integrating into existing ERPs or standing on its own. Typical results include an accelerated flow of material through production, driving dramatic improvements in on-time delivery, web and lead time reduction, and higher throughput and customer fulfillment. With that, let's get to the conversation. Hey Mark, welcome to the show.
Thanks, Sam. Thanks so much for having me.
Of course, and I am super excited to have you as well because the kind of life you have lived, especially around the manufacturing companies, their ERP implementation, and especially the scheduling need, it's going to be so fascinating to discuss that. Just to kick things off, Mark, do you want to start with your personal story and your current focus these days?
Sure. Yeah. Thanks. Thanks again for the opportunity. I have a very unique background in that much of my youth in particular, but certainly once I got out of school, was kind of watching my dad. My dad founded a number of different manufacturing ERP systems. And after I graduated from Cornell with a degree in computer science, I followed him. Actually, I went first to HP, but then later followed him as he started his second ERP system, which was called Visual Manufacturing in 1992. So he had started another one called Profit Key in the 1980s. He left that actually in 1992 to start Visual Manufacturing. Visual is now owned by Infor as of 2004. Both, what's interesting is both Profit Key and Visual used by thousands of manufacturers across the U.S., actually internationally somewhat too. But both had and still have, they're both being sold net new today, very strong scheduling functionality. And I think that goes right to the topic at hand. Now, about 8 years ago, we were looking to do something in the cloud with the newer technology and to apply all our manufacturing. So my dad, my brother Mike, actually, Dave Lane, who developed Gene from Cinder, a few others of us got together and started a company called Lilly Works. Now, what was interesting is Lilly Works started as a new manufacturing ERP system. And with this opportunity of kind of having a clean slate, so to speak, we looked at the traditional scheduling model. And we looked at it hard because what we'd found through both Profit Key and Visual, which again both have excellent scheduling functionality, but what we realized was, in spite of thousands of manufacturers using either of these products, very few were able to actually utilize this functionality to benefit themselves in terms of improved on-time delivery, improved throughput, better customer satisfaction, shorter lead times, those things, those benefits you would expect and want to have from a scheduling application. So we really thought about that and actually came up with a new approach to not just scheduling, but really managing production. And we'll talk about why I say not just scheduling as we move along here. So this was initially embedded in this new ERP called Lilly Works. The method is called protected flow manufacturing. What we realized after just a couple years in the marketplace is that while folks loved this and really like this new approach to scheduling, they didn't want to necessarily replace their whole ERP to get it right. So we came up with a new model and actually created a subset of the ERP with just that scheduling and materials functionality in it that can tie into any existing ERP system. So that's been our primary focus over the past probably 4 or 5 years now, looking for and reaching out to folks who are struggling with scheduling, want better visibility in production to get all those benefits we talked about. And that's really, we've seen some phenomenal results and what we're going to talk more about.
Yeah, exactly. And I am super excited to dig into all of that because I am personally going to learn so much today about scheduling and from your journey. But before we do that, we have one of these standard questions that we ask every single guest. And that is going to be, Mark, your perspective on business growth.
So, it's kind of a twofold answer. One is, I believe this approach that we're taking with a new approach to production management will, if not through us, through industry, maybe Apex or other organizations, will soon become the default way to manage production. And why do I say that? I think the benefits of using this methodology and implementing it quickly is huge for companies. So for growth potential for your listeners, the way I equate it is that, if you're a manufacturing company, production is the heart of your company.
Yeah.
Right. And if you look at the analogy I'd like to use is a racehorse.
Yeah.
Right. So, a typical horse has an average size heart, and it can pump blood throughout the body of that horse, to a certain degree, and that horse can run, so fast. If you look at a racehorse has a heart that's almost 3 times as big and stronger as an average size horse. And for that reason, because it can push the blood throughout the system and the flow is so much greater, then that horse can run faster and faster. Okay. And it's the same way with the manufacturing company, except it's the flow of materials. Okay. It goes back to George Plossel's saying in 1975, where he said, all benefits implied in a manufacturing company are directly proportional to the speed of flow of information and materials. Okay. So the faster you can get the right information to the people in production, the faster they can make better decisions in order to accelerate the flow of your materials through production in the right way to get all those benefits: improved throughput, faster lead times, and higher customer satisfaction levels, and of course, better on-time delivery to your customers.
Yeah, and love the analogy, by the way. And if you look at the ERP community, one of the things that I have personally experienced is, everybody tries to claim them as the racehorse. Everybody tries to claim that, I am the best at doing the information flow, in doing the material flow. So I am actually looking at your journey. Let's say if you look at visual, if I look at the visual installation, as you mentioned that thousands of manufacturers use visual, even as of today, right? So, and visual, in my experience, it was sold primarily because of the strong scheduling function. It was always the sweet spot for visual. So, in your experience, what were some of the deficiencies that you saw that, visual wasn't as good at meeting those scheduling requirements? And if you could tell me the specific examples of different manufacturing micro verticals, how the scheduling needs differ and where visual is going to fall short, I think that's going to be super beneficial.
Sure. So just for the record, visual, Profit Key or two I've mentioned, Syteline, for example, Epicor, I think there are others. A lot of these systems have really excellent finite scheduling functionality embedded in them. Okay. So I'm in no way, and again, it's fewer than we'd like, but and some companies do find success with that functionality. But most, I think, struggle with it. And it's not the software per se. It's not the specific functionality in a visual or Syteline or CSI or Epicor, what have you. It's the model. Okay. The traditional finite scheduling model was developed in the late 70s and the 80s, and frankly hasn't been touched really at all. Hasn't been improved. Now there can be some ancillary improvements around the software, but the model itself says, okay, you establish your routings, your bills of material. And by the way, it kind of goes back to the MRP model, right? Where you've got in the 70s, MRP was invented, which was a huge boon, but you're running a program to create, through your bills of materials with kind of standard lead time at each level, you're creating a material plan. And then when finite scheduling came along, it actually initially didn't even look at the material plan. It just looked at production routings, right? And said, how am I going to get these routings done, in what order, and do I have capacity to do that? And initially didn't even look at materials. So that's another thing we'll be mentioning as we move along here. Is having the visibility of not just my capacity and my load, but also do I have now, and or will I have materials in the future as I look at this plan to build. So the first thing these finite scheduling tools do, and you have to do, is run a program, right? You run the scheduling program. And the scheduling program is essentially a capacity loading algorithm, right? You're taking all your firmed and released orders and their routings and their due dates, and you're either backward scheduling it, right, or you're forward scheduling it.
Yeah.
And there are issues with doing either way. I mean, consider a backward schedule, right? So you're saying, let's plan to finish the last operation of every work order the day it's due, right?
Yeah.
That's essentially what a backward schedule does.
Yeah.
And when you think about it that way, I mean, if you talk to anybody who's been in production and manufacturing really for any length of time,
yeah,
what's the one constant factor, right? Like in a lot is change,
yeah,
right? To put it nicely, stuff happens in manufacturing, right? So you don't want to plan to finish your last operation of your work order, and then each previous operation right on its completion. You don't want to plan that way because you know that variability exists in production, and that plan is not going to meet reality very well. And this is the biggest downfall of this whole model of finite scheduling is you're using a computer program to generate a plan.
Yeah.
So it's a bit of a black box, but then once you generate that plan, you print out your dispatch lists, you send those out to production.
Yeah.
And now you have a plan that immediately comes into contact with the reality of a production floor. And certainly a few hours, maybe even minutes after you've created that plan, what happens? So something's changed.
Yep.
Something's changed to make that plan either, off significantly or completely off where it's not going to make sense to actually execute against that plan. To answer your question about finite scheduling, I think that's one of the biggest. There are others, but that's one of the biggest challenges is you're trying to execute a plan in an environment where planning isn't going to hold for very long because there's so much change. Change is constant.
Right. So obviously, when I talk to manufacturers, they have different skill level as far as their sort of appetite for scheduling goes, or their understanding of scheduling, or how they are managing their shop floor. Especially in the small to medium sized business space, they get frustrated by the software and they might end up using just the spreadsheet because, as you correctly pointed out, that when you are going to take this plan on the shop floor, it doesn't really mimic the real life situations that you are going to get. So when you talk about this finite scheduling, obviously you have mentioned that, finite scheduling is going to be based on, hey, this is the due date I'm looking for, and based on that, I'm actually going to plan it out. But you don't have any sort of buffer. You can probably plan buffer, but they are not going to actually have that real life situations. But obviously, what you could do is you could actually move around the jobs if you want to, even if the plan is generated, right? So if you were to contrast this with the newer approach that you guys are following, so how it is going to look different? Let's say if I'm the planner versus I'm the shop floor guy who's sitting on the production floor, obviously my preference is going to be, hey, generate plan as of today. If my machine is broke today, I should be able to change the plan because I'm not able to move these jobs. I don't know what to do now.
Right. And that's exactly it. Yeah. To your point, it's I don't know what to do now. There's so much change. I'm not sure what to do. So this is exactly what we did with our approach. Instead of trying to create a plan and then attempt to execute that plan in production, instead what we've done is whether it's our ERP or we're connecting to any other ERP, we're pulling the information over from the ERP and transforming it in such a way in real time to publish the priorities out in production to answer that question. So everyone in production, and we use a display. You can have a tablet, you could have a workstation or a laptop. Obviously, you could have some folks use big screen TVs, but they display in a visual way showing which job, whether it's shop wide or specific to any department, work center, even machine or person level, which job is most important to be worked on right now. So it's a dynamic priority that is always up to date. So whether it does use due date as its anchor point as its
Yeah.
as its piece of information, but due date is actually not the priority. Okay, so what we realized was that in pretty much any scheduling tool you see out there, whether embedded in an ERP
Yeah.
or an outside APS type tool, it's using due date as priority. Well, on the surface, that seems to make a lot of sense. But
Yeah.
if you're in a high mix environment, especially, you're going to have jobs that are due 2 months from now, for example,
Yeah.
that are more in danger of being late if I don't get started on it today than a job that's due even a week or two from now, right? So by using due date as a priority, you're always focused on those jobs that are due sooner
Yeah.
at the expense of and risk of not paying attention to those jobs that are due later until it comes to a point where it's almost too late and folks are expediting. So these are one of the symptoms we often see is where you're having to expedite jobs because you didn't see really when you needed to start it or the true level of urgency. And that's what this approach solves is it shows in real time at all times which job is most in danger of being late across every department, resource, and machine. So folks are, as a default priority in our approach, folks are executing on which job should I be working on next? Well, that's the one that's most in danger of being late, regardless of its due date.
Interesting. So, okay, so let me make sure I follow this along and my listeners are able to follow this. So let's say if I have the ERP system that is going to have the finite scheduling, and we agreed that, you know what, if you are going to have that, you are going to be too focused on the due date. And sometimes there are going to be other variables that are going to be the factor overall in the manufacturing situation. If you don't pay attention to those, then obviously you are not necessarily focusing on the right jobs. So here
Right.
you have incorporated some of these factors from your shop floor. So let's say if I look at my traditional ERP system, if I'm working on that, and let's say if I'm incorporating those variables as part of my ERP system, and obviously the plan is not going to be generated dynamically because you are probably working overnight the plan, and then if you want to incorporate those real life situations, then you are always going to be working on the outdated plan. So am I following this along? Do you agree with my assessment here? And then you guys, what you guys have done is, you guys are, accepting these inputs from the shop floor. And, let's say if a machine is struggling or they are not able to meet the expectation, you are also incorporating your material flow. If you are going to have any sort of signals from your material community, and if there are going to be any delays because of that, so you have combined multiple factors. So that's going to be your due date. That's going to be any delays in the material, any production issues. What else is part of the algorithm? Can you talk about that?
Yeah, exactly, and that you're dead on. So, what you're talking about, what we're talking about right now is visibility of the here and now.
Okay.
Right. So when I'm on the production floor, what I want to see right now is which job should I be working on?
Yeah.
Okay. And do I have materials for it? Right.
Yep.
And do I have materials may mean, do I even have the material in inventory if I even wanted to work on this job?
Yeah.
Has the material been issued? Okay, if it's an operation that needs material issue out of inventory,
Yeah.
or is this a midstream operation that I'm waiting for material from a
Yeah.
previous operation? Has
Yeah.
the previous operation reported any complete yet? So I should have either the material sitting over there, I could go get it and bring it over, or somebody already brought it over, right? So that visibility is key too. I want to see what's coming through and the priority of everything that will be coming through.
Yeah.
And if it's here, meaning is material here and I'm actually ready to be worked on, what are the priorities of those jobs that I could actually be working on right now? Okay. So what we're talking about is real-time visibility of the here and now, my priorities and how should I be executing right now. And this is frankly the big mind shift between our approach and traditional finite scheduling. We're not trying to create an overall load versus capacity plan against which to execute.
Yeah.
Instead, we're taking each work order and we're looking at this priority mechanism looks at the due date, but it also looks at how much work I have remaining, as well as how much time between the work when I'd complete the work and the due date. So we call that a buffer. We call that time protection.
Okay.
So we create a ratio between the work remaining and the buffer remaining. And that becomes what we call a threat level priority.
Okay.
And the idea by executing in your shop by these threat level priorities, you will maximize your production's capability to get all your orders out on time as much as possible. Okay. So we focus, when we implement this approach, we focus on three phases. And this, what we've been talking about so far, this real-time visibility of the here and now, and executing against these threat level priorities, that's what we call phase one.
Yeah. So amazing insights there. So I am working on a lot of different projects, and in my experience, when I work on these projects, the problems are always going to be with respect to integration. And since you mentioned that this is going to sit on top of the ERP, and when you talk about managing this massive data, inside your scheduling function, and you are actually trying to bring that from ERP, obviously there is going to be a lot of communication happening between your ERP and the scheduling function. So tell us, what all data points do you need for you to be able to operate this module that you have that is designed more for the shop floor, but which are the data points that you are exchanging between the ERP and your scheduling function?
Yeah, great question. And by default, we're essentially replacing, at the simplest level, we're replacing any scheduling tool that the client's using now, right?
Okay.
Whether it's spreadsheets, whether it's an outside APS or the scheduling in their ERP. So and in doing so, all we need from a scheduling standpoint to replace that scheduling tool are your work orders, the jobs, and their routings. Okay, so really on the work order header level, we're just looking for the job number, the due date, the quantity, and the part being manufactured, the status of the work order, whether it's firmed or released, and then the routings for each work order, right? So the steps of the work centers it needs to go through, and any estimated setup and run times on each of those routing steps. Now, here's an interesting note. Is that what a lot of companies get hung up on is, and it's true in a traditional scheduling tool, those estimated run times and setup times, they need to be really accurate, right?
Yeah.
In a traditional scheduling tool, because those times are what's building the schedule.
Yeah.
In our tool, it's not as critical. It's nice to have them really accurate, but it's not critical. If you have any times that are somewhat in the ballpark, then we're going to be able to use those, because we're creating an execution plan for each work order. We're not scheduling off just those operations. So the point is, if you're not confident in your estimates, and most companies are not, right, because they're not out there doing time studies every day.
Yeah.
But if you're not confident in them, then you simply add a little more time protection against the due date, a little more buffer to buffer that in.
So very interesting. So you mentioned that, I simply need probably the routing and, work orders, and based on that, I can plan. But you also mentioned that you are actually considering any signals related to materials and inventory. And ERP is a living and breathing system, and things are changing always on a dynamic basis in your ERP. And you are saying,
right,
I am going to be my live system right here. I am going to be capturing a lot of signals from my shop floor. But you don't have the real visibility of the inventory. In fact, Amisi, you did not mention that you are actually bringing the inventory data as well. And if you bring the inventory data, then you are going to need a lot more, because to know what is happening in your inventory, you probably need the entire procurement data. So what all do you need from the material perspective in your module for it to work?
Great question, and that's exactly right. So if I'm just scheduling, labor steps or work or operations, then I just need work orders and routings. But to your point, If I want to see, do I have the material or when will I have the material, then yes, I need to bring over the BOM components
Yeah.
on the work order, what materials are needed, obviously, and what the snapshot is of the inventory, purchase orders, and potentially even sales orders. Okay, so yes, we will bring all that over. Now we integrate with any ERP system, and what we typically do is schedule a time to do a refresh. So it's a net change. It's by default, it's one way. So we're just reading the ERP system and seeing what's changed since the last time we brought information over. Inventory levels, a new PO, new work orders, obviously, or even updates to the existing work orders, meaning what's been reported complete on certain operations and what materials have been issued. So you get a picture of your priorities out in production, and a very accurate one. However often you want to do that, you can do. Some companies like to do it just once or twice a day. Others want to do it, every half hour or even sooner. Not all, but we do have a couple ERPs where we actually have a real-time net change interface. So the ERPs are capable of doing notifications, kind of like triggers. So if we're using one of those, as soon as we tie in, the information passes over immediately when it's changed in the ERP system.
So the whole premise when we started this conversation was that, the information was not real time. You need the real time signals to be able to operate on the production floor. And if you don't have the real time information, obviously the scheduling function or the execution plan is now not going to be as robust. But now we are talking about this one-time refresh or multiple time refresh. So again, your data is not going to be current. Even if you have, let's say, the job data or work order, that could be current because you have a lot more knowledge from your production floor, but you don't have as much knowledge from your ERP. So it's not going to be as real time. So what are you guys doing to prevent this, that you are not really operating on the real-time information, even if you...
Yeah, no, great question. So if you want, so by default, we're going to look to the ERP for that work order status information. So in other words, what operations have been reported partially or fully complete, what materials issued, and so forth. However, there is an option in our software to actually do the reporting right in our software. So it can be as simple as, in that priority list I described out in the shop, folks can walk up to that and click a check mark and say, I'm done with that operation, and it'll drop off. So there's your real-time priority. You can also clock in, clock out, and capture times that way. So you could do that. And then there are actually APIs. So if you wanted to push information back to the ERP and then that's supported, then you can do that as well.
Okay, so great points there. So now let's talk about, the other functions that are going to be present on the shop floor. So it's not just the scheduling. Obviously, scheduling is a very important piece. No doubt about that. I completely agree with you. But then, you are going to have a lot more software components that are going to be present on the shop floor, and they all need to be talking together. And if they don't talk to each other, then we are going to be facing a lot of problems. For example, let's say companies are exploring a lot of Industry 4.0 scenarios. And right now, the problem is, if you utilize MES, which has always been sort of this, it was the role of the MES to actually do the scheduling, to be honest. I mean, MES was more of the execution system. ERP was always more of the information financial system and anything that MES needs. So let's say, if they require the MES functionality, and a lot of companies are exploring a lot of things from let's say if they have any quality sort of problems, then they probably need a quality system. They probably need a histogram. They probably need to integrate with machines to be able to do the continuous improvement. So how are you guys playing along? Let's say with the MES solution, are you going to be complementary with the MES solution? Are you going to be just sitting by the MES solution? So how is the overall architecture going to look like?
Yeah, great question. So we've encountered a number of companies and that are using our software that have had an MES already, right? But they really liked our approach to managing product, especially in terms of the priorities. So through the API, actually, they can use our tool to generate the priorities and push those into the MES. Because that's one of the things with MES is it's only as good as the priorities you're feeding it. So if you're feeding it priorities from a traditional scheduling method that people don't really trust or believe in the priorities, then you're not going to see the benefits to using it out there. So we'll do that. Another interesting point you just brought up was machine data integration.
Yeah.
So we've got also a customer that's using both of those, and then another one that's actually tying in directly to the machine data. So instead of having to even wait for an operator to report an operation complete and the quantities they reported, it's reading the quantities in real time off the machine and updating the priority status with that. So in that sense, yes, the priorities are always truly real time and as good as they're ever going to be.
So let's talk about some of the unique scheduling needs. So I understand the overall premise right now, based on what you said, that due date is probably not a good thing to look at when you are trying to deliver your execution plan. The execution plan needs to be real time. But when you go across the industries, have you seen any specific problems related to scheduling, that the scheduling is going to be different? Because when you look at different kind of machines, there are going to be crazy scenarios. For example, two people working on the machine, or machine is being used for two different processes. You have different kind of products, and then one machine is going to be much bigger bottleneck than the other machine. For example, let's say if you go to some of these companies like glass foundries, and if they have only one foundry, that becomes the bottleneck for the entire production process. So have you come across any unique scenarios related to scheduling when you go across the industries?
Yeah, absolutely. And as you pointed out earlier, sometimes they fit into micros. Sometimes it's just in general how that company is deciding to do production. But some of the things you pointed out, one of the big ones is sequencing jobs.
Yeah.
Right. So whether whether you're cutting or machining, bar of different diameters across different jobs, or paint is a classic one. When I get into paint, I want to paint the light to dark rather than, so if I have 3 light jobs, even though they're not in the same priority sequence, I want to run those together.
Yeah.
So yeah, that you can tell the software to do that with certain code. So it'll actually override the priorities and sequence those jobs with different priorities, sequence them together. So you're doing all the lighter ones at the same time, for example, right? So that's a nice benefit. The other you mentioned is people.
Yeah.
And this is a huge constraint, especially these days with COVID and people becoming, as a resource, becoming more and more of a constraint. Even you've probably seen it a lot. You encounter a lot of companies. They have plenty of machines. They don't have enough people to run them.
Yep.
So here again, you want to be able to specify, what machine does this go on? What machine out of a number of machines could it go on? And then what person or what people need to be available in order to run that machine as well. So that's important to make sure your system looks at not just one resource, but potentially multiple resources that are necessary in order to prioritize or schedule those operations.
Okay, so I want to touch on the sequencing aspect that you mentioned, and in a lot of industries that you mentioned that what sequence is going to be really critical, and a lot of people don't even understand how to buy a manufacturing software, to be honest. So let's say if they don't understand how sequencing works in an ERP system, and I don't know if your PMFM module is going to utilize some of the sequencing data from your ERP, or the driver for sequencing is going to be done inside your tool. So can you talk about how the data is going to be structured as far as the correlation of sequencing goes inside an ERP? Is it done more at the job level? The correlation, is it done at the BOM level? Do you want to talk about that?
Great question. And frankly, if the data's in the ERP, then we can use it. The neat part about PFM being a separate tool and with its integration is the integration piece is really an ETL, extract, transform, and load type of tool, with the key point being transform. So even if the data is not in the ERP, as it comes across, we can create functionality in the integration to assign what we call the setup codes to certain types of operations. So they're when they get over to PFM, the sequencing happens appropriately. Okay, but so yeah, it can come from either way, and by default we look at you can assign the setup codes typically at the operation level. So you say on a job, on this operation, use this setup code. So if it finds other operations across other jobs for the same resource with that same setup code, it's going to try to bring them together in a certain time frame.
I see. Amazing. So that's it for today, Mark. Do you have any last minute closing thoughts or remark for our listeners?
Yeah, just if you're interested in what we've talked about today and you want to see how this could potentially work in your facility, there's actually 2 more phases we didn't get to, so maybe another show. But after execution, then we actually go into a planning phase where we look out into the future and actually simulate how you will be executing, whether you're doing the setup overrides and sequencing or not, based upon those threat level priorities to see your future reality, right? So seeing it where your bottlenecks are going to be, where your material constraints are going to be in the future, and really be able to give customer service and sales a tool and production a tool, certainly, for being able to tell your customer when you're going to be able to get their order. Okay, and that's one of the other big questions that comes across. And then finally, phase 3 is where we get into the what if simulations.
Yeah.
So use your imagination, right? What if I get another machine? What if my two best setup people go deer hunting for a week in November, right? What's that going to do to my on-time delivery? What if I work overtime on Saturdays for the next 2 weekends? How is that going to improve my on-time delivery? And so on and so forth.
Yeah, and my personal takeaway from this conversation is going to be overall, if we look at the scheduling function, I think it's behind compared to the other functions in the company. For example, let's say if you look at the SNOP function, they have always had this what if scenarios, and they can do a lot of planning. If you look at the finance department, they always had CTM tool. They can do a lot of scenario planning. They can do a modeling. So now it's commendable that you guys are doing that for scheduling as well. So on that note, I really want to thank you for your time, Mark. This has been a fascinating conversation.
Thank you very much, Sam, for having me. Appreciate it.
Of course.
I cannot thank our guests enough for coming on the show, for sharing their knowledge and journey. I always pick up learnings from our guests, and hopefully you learned something new today. If you want to learn more about Mark, head over to lillyworks.com. It's LILLYWORKS.com. Links and more information will also be available in the show notes. If anything in this podcast resonated with you and your business, you might want to check other related episodes, including the interview with Matt Goosey from MRS Machining, who discusses the challenges associated with manufacturing complex parts in short runs. Also, the interview with Dave Griffith, who discusses why manufacturers must look for low-hanging fruits when exploring the path of Industry 4.0. Also, don't forget to subscribe and spread the word among folks with similar backgrounds. If you have any questions or comments about the show, please review and rate us on your favorite podcasting platform or DM me on any social channels. I'll try my best to respond personally and make sure you get help. Thank you, and I hope to catch you on the next episode of the WBS Podcast.
Thank you for listening to another episode of the WBS Podcast. Be sure to subscribe on your favorite podcasting platform so you never miss an episode. For more information on growth strategies for SMBs using ERP and digital transformation, check out our community at WBS.rocks. We'll see you next time.